What I'm about to show you is a single method that will help you answer a wide variety of percentage questions. Try not to deviate from the steps or take shortcuts. This is all about the method. And following a series of steps has two big advantages. Firstly, you are much less likely to make a mistake. And secondly, you are much more likely to remember what to do when you're just repeating a series of well-rehearsed steps. Step 1, write down the formula and bar as below. Step 2, use the bar to work out the decimal multiplier, and I'll demonstrate how we use this now. Our starting point is always 100%, and we'll move up or down from this point. So for example, the value of a car goes up by 20%, so we'll move up 20% to about here, which will be 120%. And we can see the decimal multiplier for this would be 1.20. We can see here the value of a car goes down by 20%. So we go down to about here by 20%, so we arrive at 80%. And the decimal multiplier in this case will be 0.80. Finally, the value of the car goes to 20%. So we go all the way down to 20%. And so the decimal multiplier is 0.20. But in this question, we can see that Derek invests £800 in a savings bond, and after a year they have gone up in value by 8%. So we start always at 100%, we go up by 8%. So we'll get to here, 108%. And we can see here then that the decimal multiplier will be 1.08. Step 3, put our known values into the formula. Well, the decimal multiplier we've just found is 1.08. And £800 is actually what I start with. Step 4, solve the equation. Well, this is easy with a calculator, and I find the result is £864. Here's a different question. Step 1, we write down the formula and bar. Step 2, we use the bar to work out the decimal multiplier. We always start at 100%, and we can see after a year it's depreciated by 18%. In other words, it's gone down by 18%. And this will take us to roughly here. And so we've gone down by 18% to 82%. And we can see the decimal multiplier would be 0.82. Step 3, put known values into the formula. Well, the decimal multiplier we found to be 0.82. And Terry started with £13,600. Step 4, solve the equation. And again, this is straightforward with a calculator, and I get £11,152. In a shop, everything is reduced by 20%. Walter buys a coat in the sale and pays £200. What was its cost before the sale? And this question is known as reverse percentages because I want to know the amount before it went up or down. Step 1, as always, write down the formula and the bar. Step 2, use the bar to work out the decimal multiplier. We always start at 100%, and because everything was reduced by 20%, we moved to approximately here. So we've gone down by 20% to 80%, and so we can see the decimal multiplier is 0.8. Step 3, put known values into the formula. The decimal multiplier is 0.8, and £200 is what I ended with. I'm trying to find what the starting price was before the sale. Step 4, solve the equation. Now this is different to the previous two because you can't simply put this straight into the calculator. Some unknown number multiplied by 0.8 results in the answer 200. And don't forget, the reason we've been learning all this algebra is to help you in just this sort of situation. and you should have no trouble in seeing that we're going to divide both sides by 0.8 to get the answer. And we find the coat initially cost £250. Josella buys an antique at auction for £70. She sells it in a shop for £95. What was her percentage profit? Again, this is slightly different as you're given the start and end values, but asked to find the percentage. However, the method still works. Step 1, write down the formula and bar, as I've done here. Step 2, well, we haven't got a percentage to write into the bar, so we skip this step. Step 3, we put our known values into the formula. We started with 70 and finished with 95. Step 4, solve the equation. What we have here is 70 times some number is equal to 95. And similar to the last question, you should know that we're just going to divide by 70 to find the value of x. And to 2 decimal places, you'll find that x is equal to 1.36. So this is our decimal multiplier. Now we're going to put this 1.36, in roughly the correct place on our bar. So 1.36 would go here. And I can see that the equivalent percentage to 1.36 is 136%. And again, if you've understood this bar, you should see that I've moved from 100% to 136%. So I've gone up by 36%. So 36% was the profit. Bear in mind, we're always starting from 100% when we read or use this bar. The population of a colony of polar bears is decreasing by 8% each year. To start with, there are 200 polar bears. How many are left after 8 years? Well, this is a compound interest question since we're going to apply the same percentage decrease 8 times. We start in just the same way. Step 1, we write down the formula and bar as I've done here. Step 2, we use our bar to work out the decimal multiplier. We start at 100%. Polar bear population is decreasing by 8%, so we go down 8%. And this takes us to 92%. And so the decimal multiplier is 0.92. Step 3, we put our known values into the formula. So the decimal multiplier we've just found is 0.92. And we know the colony starts at 200. Now this is where we make a slight modification. Because the same percentage change is applied 8 times, we simply add an index here. And so step 4, we solve the equation. And this is straightforward using the calculator. 200 times 0.92 to the power 8. And you'll find to the nearest whole number, we get the answer 103.